Okay, so you've seen the headlines, heard the buzz about the temperature records lately, and you're probably wondering, what does it all actually mean?
Right.
Well, you're in the right place. Today on the deep dive, we're looking closely at something you pointed us to.
Yeah.
This article, Global Temperatures at Historic Highs, Europe Records Hottest March Ever.
Hmm.
Our goal here is, to get past the headlines, dig into what's really significant, and give you a solid grasp of what's happening with the climate right now.
Absolutely. It's a really important piece you flagged. And this article, drawing from Copernicus Climate Change Service data and other related sources, gives us quite a bit to work with.
So we're going to break down that record March heat in Europe, put it in the global context,
Yeah.
look at some potential reasons why, and, well, what it all implies.
Sounds good. Maybe starting with Europe makes sense. The data there was particularly striking.
Yeah, definitely. That headline alone grabs you, Europe's hottest March.
Ever.
It does. But digging in, it wasn't just like barely breaking the record, was it? The article says it was by a significant margin, according to Copernicus. That really jumps out.
It really does. We're talking 0.26 degrees Celsius above the old record from March 2014. Now, that might not sound like a huge number on its own,
Right.
but in terms of global climate averages, a jump like that for a whole month, that's quite substantial. It signals something pretty intense happening in Europe.
It suggests things might be speeding up there. Maybe more than models thought.
They could well do. And it really highlights the intensity of the heat Europe felt. It's not just a tiny blip.
And it wasn't just heat, right? The article connected it to rainfall extremes, too. Sounds like things were pretty chaotic.
Exactly. And that's one of the really concerning parts. Samantha Burgess from Copernicus pointed out this stark contrast.
Yeah.
You had some parts of Europe having their driest March on record, while others got hit with their wettest in like 50 years.
Wow. So completely opposite extremes happening at the same time.
Precisely. It really shows how a warming climate doesn't just mean warmer everywhere. It means more volatility, more unpredictability. It destabilizes the system.
Yeah, like it's losing its balance. And that quote from Bill McGuire at University College London seemed to capture that perfectly. He said it shows clearly how a destabilized climate means more and bigger weather extremes.
Mm-hmm.
And then he added, as climate breakdown progresses, more broken records are only to be expected. That's quite a statement.
It's sobering, isn't it? And McGuire's point is key. We shouldn't see these as just isolated freak events anymore. They're part of a pattern.
A direct result of the long-term warming trend.
Yes. And we have to remember, the article notes Europe is warming faster than any other continent.
Right, making it especially prone to these kinds of record breakers.
Exactly.
Okay, so Europe was clearly a major focus. Let's widen the lens now. What did the article say about the global picture during March?
Well, globally, it was the second hottest March in the Copernicus data. But, maybe even more worrying than that single month, the sheer persistence of the heat. The article talks about a near unbroken spell of record or near record-breaking temperatures going all the way back to July 2023.
Wow, that's, what, 8, 9 months straight?
Something like that. A really significant, sustained period running way hotter than normal.
It really feels like we're in new territory. And the article kept bringing up that 1.5 degrees Celsius number compared to pre-industrial times.
Yeah.
March was 1.6 above, it said. Why is that 1.5 figure so important?
Yeah, that 1.5 degrees C threshold, that's relative to temperatures before the Industrial Revolution, sort of 1850 to 1900. It's the key target from the Paris Agreement.
Okay.
Basically, scientists determined that warming beyond that level dramatically increases the risks of really severe, maybe irreversible climate impacts.
Like what?
Well, much more intense heat waves, significant sea level rise, major disruptions to ecosystems, really serious stuff. So consistently going over 1.5 C, even month by month like this,
It's a bad sign.
it's a very strong signal that we're accelerating towards those higher risk scenarios.
It is definitely concerning seeing those numbers stay so high for so long. And the article mentioned something interesting, that scientists thought temperatures might drop off a bit after the El Nino peaked early this year,
Right.
but they haven't. They've stubbornly lingered, as the article put it. Why is that? What are people thinking might be going on?
That's a really good question, and it's something scientists are looking at closely. The fact that the heat didn't really subside as much as expected when the El Nino influence typically wanes, well, it suggests the underlying warming signal from greenhouse gases is just getting stronger.
So the human-caused part is becoming more dominant, maybe overriding those natural cycles more.
That seems to be the implication. It's becoming harder for natural variability like El Nino to mask or counteract the long-term trend. Robert Votard from the IPCC called it an exceptional situation,
Right.
which really tells you how unusual this persistent warmth is, even to the experts. They might be looking at whether this El Nino had a longer tail, or if other climate cycles are interacting in unexpected ways, or maybe just that the heat trapping effect is stronger than we thought for this point in time.
Okay, so all this heat, Europe and globally, what does it actually do? The article talked about the implications of warming. What are the key impacts we need to grasp?
Well, exactly. As Friederike Otto from Imperial College London said, we're very firmly in the grip of human-caused climate change. And what that means fundamentally is that every little bit of warming makes extreme weather more likely and more intense.
So more heat waves, heavier rain, worse droughts, that kind of thing.
More frequent, more severe versions of all of those. It's like turning up the volume on the climate's natural variability, pushing it into damaging territory more often.
So it's not just about it being a bit warmer on average.
Not at all. It's about the whole system becoming more volatile, more energetic in damaging ways.
And the article stressed it's not just air temperature either.
No, that's crucial. It's about all the extra heat trapped in the atmosphere and in the oceans because of greenhouse gases, CO2, methane, and so on.
And warmer oceans mean?
Well, warmer water evaporates more easily, so you get more moisture pumped into the atmosphere. And that warmer, wetter air can then fuel heavier rainfall, bigger floods, and also provide more energy for storms. It's all connected.
Which explains those rainfall pattern shifts we saw in Europe, the super wet and super dry places.
Exactly. It disrupts the normal patterns. The article even gave specific examples from March, that heat wave in Central Asia, and really tragic, deadly rainfall in Argentina.
And the implication is that climate change likely made those events worse than they would have been otherwise.
Yes. While you always need specific studies to pin down the exact climate change contribution to any single event,
Sure.
the overall trend of seeing more frequent and more intense events like these lines up perfectly with what the science predicts in a warming world. They're stark reminders of the real-world costs.
Okay. Then the article moved into what it called the puzzling aspects.
Yeah.
It sounded like even scientists are finding some of what's happening now particularly intense, maybe a bit surprising.
Yeah, there's definitely that element. While the main story, long-term warming driven by emissions, is crystal clear, the rate and intensity of the recent heat spike has brought up some questions.
Like the fact that 2023 and now early 2024 have just blown past previous records.
Right. And 2023 being the first full calendar year over that 1.5 C mark compared to pre-industrial times, that's a big milestone, even if it's just 1 year for now.
And the article was careful to point out that 1 year doesn't mean we've permanently crossed the 1.5 C long-term average, which is measured over decades.
Correct. That's an important distinction.
But the warning is it makes staying below that long-term goal much harder.
Absolutely. It's a serious warning flare. The article mentioned that back in October, the estimate was we were at about 1.36 C warming already.
Right.
And on the current 30-year trend, we could hit the 1.5 C average around June 2030.
Wow, that's not far off at all.
No. It really highlights the urgency.
And just to be clear, the main driver is still understood to be burning fossil fuels, right? Even with these puzzling aspects.
Oh, absolutely. The overwhelming scientific consensus on that hasn't changed. Human activity releasing greenhouse gases is the primary engine of the long-term warming. Natural climate cycles, like El Nino, add wobbles on top of that trend year to year.
But they can't explain the sheer size and speed of the underlying warming.
No, not even close. The evidence for the human fingerprint is overwhelming.
Okay, but then what are these other factors scientists are looking into for this recent record heat spike? What else might be playing a role?
Well, this is where it gets really complex. Robert Votard's comment about phenomena that remain to be explained kind of captures it. The temperatures, while extreme, are still sort of within the upper bounds of what models predicted could happen. But the intensity has people digging deeper into other potential contributors, things that might be amplifying the main effect.
And the article listed some possibilities. Clouds, pollution.
Yeah, things like potential shifts in global cloud patterns. Clouds have a huge impact on how much sun energy gets reflected or trapped.
Okay.
Also, changes in airborne pollution, aerosols, those can actually have complex effects, sometimes even a temporary cooling one, so changes their matter.
Right.
And even looking at Earth's natural carbon sinks, forests, oceans, and whether their ability to soak up CO2 is changing. If they become less efficient, more CO2 stays in the atmosphere, speeding up warming.
So lots of moving parts in the climate system.
Definitely. These are all active areas of research trying to fine-tune the understanding.
It's a good reminder that while the big picture is clear, the details are incredibly intricate. And the article briefly touched on the data behind all this.
Yeah, it's staggering, really. Copernicus uses billions of measurements, data from satellites, ships, aircraft, weather stations all over the world.
That's how they build up that global picture.
Exactly. And while their main digital records go back to 1940, they also mention how scientists use other things, ice cores, tree rings, coral skeletons.
Right, to look much further back in time.
To get a sense of climate history over thousands, even hundreds of thousands of years.
Which led to that final, pretty stunning point in the article, that this current period is likely the warmest the planet has seen in something like 125,000 years.
Yeah. That really puts the unprecedented nature of what's happening now into perspective, doesn't it?
It really does. Okay, so let's try and wrap this up for our listener. What are the absolute must-know takeaways from digging into this article?
Okay. Well, first off, Europe's March was record-shattering, not just hot, but also with those wild rainfall swings showing increased weather volatility.
Got it. Europe's extremes.
Second, globally, March continued this really alarming streak of exceptionally high temperatures that started way back last summer.
Right, the long run of heat.
Third, this reinforces the core message. We are deep into a period of rapid human-caused global warming.
Driven by greenhouse gases.
Exactly. And fourth, this warming isn't just abstract numbers. It directly fuels more intense and frequent extreme weather events worldwide.
The real-world impacts.
And finally, while the main cause is known, scientists are still actively investigating the specific factors behind the sheer intensity of this recent heat spike, reminding us the climate system is complex.
Okay. So it really hammers home how urgent and serious the situation is, seeing these records tumble and hearing scientists trying to understand the finer points of why it's happening so fast right now.
Absolutely. And, maybe that leaves you, the listener, with something to think about. Given how remarkable, even to scientists, these recent temperatures are, and the ongoing work to fully grasp all the drivers, what other questions does this raise for you about, the planet's future, or maybe about the climate information you see day to day? It's definitely a complex picture, and staying curious and informed seems more important than ever.